This is the review for the Bernoulli distributions quiz. And you're probably going, wait, what are Bernoulli distributions? I don't remember you saying that. Well, I did in the notes. But Bernoulli distributions means you have a probability of success or failure only. And your probability P is a number, and it doesn't change, all right? Each trial is independent of the other. So let me and if it's geometric, you're looking for the probability of first success. And if it is binomial, you're looking for the probability of X successes out of N trials. So this N right here is super important, all right? Because if you know that, then let me see if I can do it again. There we go. Lets me do red in there. Yes, yay. So X successes out of N trials, that's important, okay? Whereas this is just the probability of first success. Okay, and if you're looking for formulas, you're mainly going to have to focus on binomial distributions, okay? That tends to be the one that we are working on in AP Stats. Geometric distributions used to be a little bit more emphasized, but those are going to be phased out in the future, not necessarily this year. And but the formula is pretty intuitive, and you can find it on the formula chart. So when you're taking today's quiz, make sure that you know the two formulas. So I actually probably can show you the formula for, well, actually what I'll do is I'll show you how this gets filled in for one of the examples. All right, so when it's appropriate. So looking here, actually, you know what? I'm going to do this as an example. That's fine. We're fine. So let's go ahead and go to our first problem. Color blindness occurs in 6% of Caucasian males. You screen 200 Caucasian males for color blindness, and then we have our questions. In the screening of this population, what is the probability the first male diagnosed is the 10th person checked? So you see the first. That is your key that this is geometric over here. So right over here, that would be geometric distribution. Okay, go ahead and do that. So geometric. And the way you fill in the formula, you have X is 10. So let me write that down. I didn't. So X equals 10. And P, actually later. P equals 0.06. All right. So I usually have my students try to write those down before they even do a formula. And you can basically just do 1 minus 0.06. So where are they doing that? Let's go ahead and show you. So there's the P right there. So that is the 0.06. Let me go ahead and put a 0.06. And so this is going to turn into 1 minus 0.06, which is going to be 0.94. And actually that P goes there too, right? And then the X in this case is 10. So you see that 10, that's your 10. And then your X, you put your 10 in there too, in that little thing here. So you should write it both here and here. Looks like they like uppercase. So I'm going to go ahead and make that uppercase. Excuse me. Okay, so once you substitute in and multiply the formula, that is it. So if you're showing work on this problem, because you guys are like, I want the points. Yes, I know. This is the work right here if you're doing it by hand, all right? You could actually say, here's another way of, I'll show you first on the TI how to do it. So here's a TI notation, since everyone has access to TIs. So let me go ahead and I'm going to do second distribution. And you got to scroll till you get down to geomet. There it is. Okay. Put in your P, which is 0.06. Put in your 10. And there you go. Now, if you copy just straight off this screen over here where it says Geomet PDF, you will not get full points if you don't tell me what the 0.06 is and the 0.10. So I'm sorry, not 0.10, the comma 10, so 10. So we got 0.03438. That looks the same. Now let's go and we're going to play with the numworks calculator. And we're going down to distributions as well. All right, hit OK. And this is geometric. They do have geometric on here. It is a little further down, but it's not too far down. And then we're going to put in 0.06. All right, notice it doesn't even give me an n. And I want the probability that it's on the first try, and I want an exact value. So I need to come down here. So the way we did exact value on the calculator is we just basically said PDF instead of CDF. All right, so oops, I have a mistypo here. This is PDF. I was trying to do the P, delete the C, but apparently I did that. So that P is super important. Let me go ahead and highlight that P right there. That is super important. In fact, let me underline it because it's telling me that I'm only going that far. Okay. Now here, since I'm not doing the triangular notation, it's very visual. And so you would be saying, okay, we want X is 10. Oh, I'm on the wrong thing. Did I start to type? No. All right. I'm on the wrong screen. So I'm going to put 10 here. And there it is. Same answer, 0.0343. Now, 344. So 3438, same idea. On quizzes like this, always give me 3 significant figures. So that would be to the 343, the third number that's after the zeros. That's your significant figure. If you want to round correctly, you look at the fourth number and you round appropriately. All right. Then, of course, some of you are going, wait a second, Mrs. Overman, I don't have a numworks calculator and you're not going to let me use my phone on the quiz. So, good news. Until you decide if that's the way you want to go. In the fall, we use a Statlet. And, they don't have geometric. So for geometric, what you would do is either use the TI and get this value, or you would write the formula. All right. And the other way to show work. So these are 3 different ways to show work. Or write down geometric. P equals 0.06. So you're kind of doing what you're doing up above. X equals, and then just say probability X equals 10 is, so that's another way to show work. Is if you tell me the distribution and what the values are in that distribution, then you get credit. All right. So, and in fact, you can see I don't have the formulas on problem 2, but I'll go ahead and show you the problem 2 formula. So that's the main thing. We need to know, which distribution and what the values are for that are needed and that you're calculating. All right. So it feels like, wow, that wasn't very much. No, it wasn't. Okay. Now let's go to problem 2. What is the probability exactly 20 are colorblind? So you can see we don't have first here. We have exactly 20. All right. So there we go. Exactly 20. So that tells me that X equals 20. In fact, I'm going to go ahead and just add it in here. So you can just tell me that it's a binomial distribution. N is 200, P is 0.06, X is 20, and give me the answer. All right. Let's go ahead and do the TI version. Make sure that's a PDF. So you have to say, okay, I'm going to which distribution now? We're going to the binomial distribution, which is a bit down here. Sometimes it's faster to go up and then wrap around. So here you see the difference between this and geometric. Geometric just asks me for P and for X. So here we're doing 200 trials. Let's make sure our answers are correct. 0.06. And the value is 20. All right. Paste. And boom. And I get 0.00. You know what? I'm going to be true to my word and do 3 significant figures. 59. So 0.00859. I think I did it just because it was a little tight on that line. Let me go ahead and do the 59 here. There we go. That's a 3 significant figure answer. And then let's go ahead and we'll go to the calculator. So numworks, to go back on your distribution, so you hit this little back arrow. We want binomial. And we know it's binomial because we actually have a number of trials. We have 200 trials. And by the way, if you don't have that n and you go to binomial, you're like, oh, it's really wants that binomial. Probability of success is that. And we want an exact. So we need to go back here and change it to this exactly one value. And we're doing it 20. And there you go. That's it. And you can see it shows a little line right there on the screen. And you can say that that's what you're looking for. Okay, and then if you're using Staplet, which works just fine for this, you go binomial distributions, put in 200.06, and plot your distribution. And then, in a way, one of the advantages of the Staplet is it actually has words. So you have exactly, and you put 20 in there. And you go. Boom, there's your answer. You probably noticed, oh, the rounding's not so good, so let's do that. I personally prefer my answers as decimals. Let's say 5 digits of precision. 5. I always just change all of these to 5. And then done. And then hit go. And you can see, oh, it's doing 0.0086. So you know what? And sometimes it's going to be, I'll be lenient. If it's doing that on the Staplet, I'll take your 0.0086. So unless Staplet, because Staplet can be kind of annoying. Let's see. Is there any way? Well, that's weird. It says always round to 5 significant figures. It should do that. Let's see if I said 3. Will it behave better? Sorry, I'm just exploring. Go. No, it seems to want to stop at 4th decimal place. So give me the 10,000ths or 3 sig figs, whichever one works, all right? So there we go. So those are the answers for number 2. What is the probability that at most 20 are colorblind? So you can actually just change this drop down. Oh, and let me make sure you guys know how to show work. So if you're using Staplet or the numworks calculators, tell me let me do this. I like to do the yellow as the work. I need to know which distribution, what is n, what is p, what is x, and the answer. That's it. Okay. You do not have to draw this picture at all. In fact, they never expect drawings on this. So now we're looking for at most 20. All right. So we'll go backwards. We'll do Staplet first, since we're right there. We change it to at most 20. Go. Boom. All right. Yeah, it seems to like 4 decimal places a lot on here. On the numworks, we got to change this to, so it's the left-sided, because at most, we need to make sure, oh, and actually your Staplet, if you're confused, you're like, I'm not sure what at most means. At most means equal to that number and to the left, all right? So if you're having trouble with the vocab, which happens, you can use the Staplet to help you fix your vocab. And there's the numworks. I just changed it so the graph was left. And see how it says less than or equal? Notice that's different than less than, okay? And then let's go to binomial, to the calculator, the other calculator. So we go second distribution. We're going to do CDF. I'm going to go from the bottom. See, it's about the same either way. So we have 200 trials, 0.06, and we're doing 20. Oops, not 2, 20. There we go. My keyboard was being weird. And you get the same answer. All right. Now, let's go to less than 20. So here on the calculator, 20 is not less than 20. You got to go 1 down. So if I do that again, second distribution, CDF, I want all the values from 0 to 19. All right. There you go. 0.982. So it does change. It should be different. At most and less than should be different, even though they're very similar. All right. So if I go to the numworks, See how this is here? And it doesn't really show me, it doesn't trace down there or anything like that. So here this says less than or equal to 20. I want to make sure I change that to 19. I still have the distribution up, so I just changed that. And you can see we had the same answer. And then if we go to the staplet, we already did that, at most 20. No, we want less than 20. Less than 20. And hit go. Oh, yeah. So less than 20. Notice that I didn't have to change this to 19 because it has the less than word. So it knows this piece right here. Let me go ahead and highlight this. It knows less than and less than are equal to. All right. By the way, there's a pretty symbol, but Cammy's kind of funny with the symbols these days. So I'm avoiding some symbols and using old typing shorthand. So less than or equal to, I just put less than equal to. All right. What is the probability that at least 20 are blind? So basically that is greater than or equal to. So I take away everything less than 20. So that's really, let me go ahead and do this as one more line. Technically, that is, there we go. Let me add in a line. That is because the calculator, the TIs, this is really for the TI I'm doing this. The TI only does, well, and actually the NumWorks only does it too, come to think of it. I have to actually make that adjustment. So adjust this part right here. So both calculators only do less than or equal to. Calculators only do less than equal to. All right. So you have to change that. Now, I will say this. Okay, so let's do, so on the TI, you have to do this 1 minus that 0.0982, so 0.9821. You have to know that. On the NumWorks calculator, you can actually, instead of doing that, so the NumWorks will do greater than or equal to. So when I write that, I'm like, well, that's technically not true. So what I can do is just change this graph, pretend I'm on my, come on. Let me refresh my thing. So what I can do is I can just come over here and then change it to greater than or equal to. Come on. There we go, hit OK. Then go over here and make that 20. And there you go. I get the answer. So the nice part about the NumWorks versus the TI is the TI just doesn't do greater than or equal, but the NumWorks does. So if you wanted to, actually on the NumWorks, you would just write down the binomial distribution, and you can actually tell me greater than or equal to 20, and then just give me the number. Okay? So you can give me those values. I'm going to go ahead and show, most of you are using TI, so I'm not going to really change the work so much. Maybe on the other side when I do that. Okay, we have 6 sets of experimental goggles that may help colorblind patients. What is the probability that we have enough goggles, I might go change that, for the group being screened? So we want to know the probability. How will we know if we have enough? So that is, let me go to binomial distribution because it helps me with the words. That means at most, all right? So X, and let me make that note, X is at most 6. So that's equal to, that's the same thing as less than or equal to 6, all right? It doesn't get bigger than 6, all right? So if I'm doing it over here, I can say at most 6. And you can see that I'm probably not going to have enough. There's only a 4% chance that I'm going to have enough. All right. If I go to the NumWorks, I'm already on at most. So I just change that to 6. Wait, let's make sure we're on. Oh, nice thing here. I can see I'm on the wrong side. At most. Make sure I'm at most. and then go to 6. There you go. Same answer, 0.04125. For the TI, we're going to go second distribution, binomial CDF, and then just say 6. And you get the same answer. Okay. Then I'm going to go ahead and go to the other side, partner B. And was there anything? Yeah. There we go. Okay. So let's start at the beginning. We're doing geometric again. So let's just make sure we're really just going to double check our answers, doing it the same way you did here. Again, this is first male diagnosed. So we know it's geometric. All right. And it's Geomet PDF right there. Okay. So you can use the formula, or you can tell me what distribution. P equals 0.03. And then you just go probability that, tell me what distribution first. Probability x equals 20 is 0.0168. So let me go ahead and show you how that works. Let me do that so you can read it a little better. And my little dot can, I'll erase that. There we go. So make sure that you're getting the right distribution. So you can use the formula to show your work. It's great. I'll show you how to use the formula over on the, it's kind of hard on here because I don't have the notation. I could write it by hand. I might add it in. But you can also, there we go. So let's go ahead and do geometric. So we're going to do second distribution, geometric. I'm going to go backwards. Oh, there it is. Geometric, it really is faster to come from the bottom. We're doing PDF because we're doing an exact value. Now we're 0.03, and our number of trials says, we're not doing trials yet. And we want to know the probability of the first one diagnosed is the 20th person. And then, boom, 0.0168. All right. If you're doing the number works, we got to change distributions. Go to geometric. Okay. And our probability is 0.03. And we want probability that we want a discrete line. So this is like PDF on the numworks. And we want that to be the 20th person. And there you go. And again, it's not available on the Staplet. They just expect you to kind of use the formula, which I guess they were kind of prescient because it's like, if you look, there is no geometric distribution on here. And it's kind of going away. So maybe that was a hint from Staplet. You don't really need it. And again, don't forget you have your formulas here. I'm going to go ahead and show this on the next problem. So if you're doing binomial, remember the other way, if you show the formula and you have the formulas in front of you on the chart, okay? So you could, let me go ahead, there we go. You could put the N and the P. So for this one, I'm going to use this one for partner B. N is, I keep wanting to go to my other tools. In this case, N is 500. And X is 20, right? 10. X is 10. All right. So let me write down X is 10. So what would this look like? Well, let me show you on the calculator. It's probably easier to do it on the calculator to show you. All right. So if I was doing this, the way I'd go, let me go home and hit calculations. The reason I'm doing it on this calculator instead of the other one is it actually shows the formulas a little bit better. So we actually have, let me see if I can do it this way. Actually, I'm going to do, yes. So we have, it should be counting probability. There we go, probability. And then you go, I hit the toolbox is what I hit. Now, you're normally not going to have to do this, See, look, it matches the formula. It's a combination. So I just put in the first number is n, and the second number is 10. All right. Then we go times, it's going to be your p, 1 minus p, minus 0.06. So you're going to have, actually, I think they did p first. We're going to do it in the right order. So it's going to be your p. So how many times does p have to occur? Here, I'm going to temporarily move this over here so you can see what's going on. All right, so I'm doing that formula. So I'm doing p, and I hit the upper arrow to go up, to the x. So we have 10 successes, all right, times, and then you have 1 minus p to the n minus x. I'm going to do parentheses there just to be safe. In this case, it's 10. And then you hit enter. Oops, let's see, did I do that right? I think it thought the x's. All right, let's try that again. It doesn't like the x's, so let's just do it. It's probably say, oh, you can do this much easier. So we're going to do that again. 510.06 to the 10 times. I think I had an X instead of a. I hit the X on my keyboard. That's why it didn't work. Oh, go up. And the way you can go up is the up arrow, by the way. So this is one way you could show this on the calculator. All right. So 500, let's see, 10, yes. I'm getting a very small number. So I did n minus x. I haven't done this in a while, so I'm just double checking. All right, so let's go see if we get a very small number on this one. Okay, back to our problem. Oh, let me put my calculator back where it was. Probability exactly 10. 1 minus 500. It should work. Okay, maybe I'm like, oh, it's not behaving. So let's go back to our probability distribution, which is way easier. This is why you probably shouldn't use the calculator. It's like, why isn't it working? Pretty sure that's wrong. Okay, so we need to go out of the geometric and go to binomial. Hit OK. Put 500 trials. Point. Oh, I know why. I have 0.06 in there. It's supposed to be 0.03. That's why it didn't work. Let me go back to my calculations. That's why I wasn't getting the number. I have the wrong number. Let's try that again. So we'll hit the little toolbar, go down to probability. Mrs. Everman's stubborn. Combinatorics. Helps if you have the right one. 500. Yeah, because I was thinking of the last problem. It's 0.03 times 0.03 to the 10th. Come down times 1 minus 0.03 to the, got to go in the exponent, 500 minus 10. There we go. Did I do something wrong again? Maybe we should, I know what I did. I put 0.03 in the thingy. Okay, so let's try to hit that little toolbar. You guys are getting tired of this, sorry. 500. Well, hey, I'm just demonstrating all the ways you can mess up on doing the formula, which is why we don't tend to do it. It is easy to, there we go. And then go up 500. So make sure all those numbers match. You can see I goofed and I put the 0.03 in the formula. There we go. That matches our actual answer. It helps when you use the numbers in the problem. So, moral of the story. Use the easy things. Go ahead and use the distributions. Do not calculate things by hand. If you don't, I coach calculator and I still make boo-boos. So I'm much better at these distributions. So, all right, and let's make sure that's right. P 0.03, and we want exactly. So we're going to come here instead of typing in that horrible formula. We're going to do that, and we're going to change this to 20, and boom. There's the answer. Well, let's see, I got We said, oh, not 20, 10. There we go. Now I have the right answer. So make sure you put in the right values, okay? And that first person being the 20 threw me off. And of course, last but not least, you're going, but Mrs. Overman, I'm using a TI, so let's go use a TI. We're doing Binom PDF. Make sure you do the exact. There you go. All those answers match. All right. Okay, then let's scroll on down, and we're going to do number 3 now. So, yeah, you saw the formula. It was kind of a pain. Be careful with it. Okay, what is the probability at most 10 are colorblind? So CDF is at most. Okay, let me make a note. CDF is at most. So you don't have to do anything fancy. You can just go ahead and work it. By the way, when you're taking your quiz, I might change the order of these because I don't want you just running through. I want you thinking about which one's the right one to do. So let's go distribution. Now, instead of PDF, we're doing CDF. Again, make sure you're putting these numbers in correctly. It's very easy to make mistakes. And boom, 0.11478. That matches what I had. And here I already had, let's do at most. So let's make sure we come back here, do at most, and change that to 10. Same answer. And then if you go to the Staplet, because you don't have your own cool NumWorks calculator, make sure you have 500, 0.03, plot the distribution. And the nice part here is you get to actually pick the word, at most 10. I keep wanting to put 20 in. Very strange. All right, next, what is probability less than? So the nice part on this one is you can just say less than, and there you go. And it gives you a slightly different number, right? Now, it's very hard because our sample size is so big to see the shift there, but this is the box that we're looking at right here, okay? And it got a teensy bit smaller. So if you're doing less than on the NumWorks, you just do the adjustment here because there's no less than option. It's less than or equal to. So less than 10, what's the biggest number less than or equal to 10? I mean, less than 10 is 9, and there's your answer, all right? If you're doing the calculator, you have to go get the distribution again. Now, you do see that you're having to get the distribution every time. So it's kind of annoying. But on the bright side, it keeps these numbers the same. Boom. And there you go. There's the answer. All right. What is the probability at least 10 are colorblind? So what we have to do, if you were to write the sample space, all right, let me go ahead and do that. So we want our sample space. Let me go ahead and we can have 0, 1, 2, 3, 4. So this keeps going all the way to 500. All right. So we want at least 10. So the reason is, why am I drawing this? The reason I'm drawing this is primarily for the TI people. All right. Because it doesn't have an at least 10. So let me move this here. There is no at least 10. So you have to figure out what's going on. Well, at least 10, what we're looking for, our answer is over. I'm going to color it purple because we're the raters. We want 10 and higher, right? So that means we don't want 9 and lower. So if you're using a TI, you can basically say, this is acceptable work. This actually what you had here, especially since you already calculated it, you could just say equals 1 minus binom CDF, n equals 500, p equals 0.03, and x equals 9. All right. And that will give you the same answer. Now, the other work you could do, or you could say, if you're doing like a NumWorks or a Staplet, tell me the distribution, tell me n, tell me p, and then give me what you're looking for. X is greater than or equal to 10. You don't have to do the 9 adjustment for the other technologies. All right. So you can pretty much do that there, and you can see, let's go ahead and do it. So if I was doing Staplet, these are the other technologies. We're going to say at least 10. Yeah, at least 10. And you can see my answer was 0.9331. Here, the calculator, so the numworks, the other side, is the at least side. So let's go here. Change that to 10. There you go. And you get the same answer. Okay. And then we have 12 sets of experimental goggles that may help. What is the probability we have enough? So that means we want at most. So that we want the probability that we don't run out means we use at most 12 sets of these goggles. All right. And you can see it's 26.38. If you're doing the binomial distribution, use at most 10. There they are. 12 sets of goggles, not 10. There you go. That matches. And if you use a TI, second distribution, binom CDF, we're doing 12 goggles. So the only thing that changes is 12. Well, make sure it says 12. There we go. And we have the same answer. So now let's go to the back side. All right, you're going, what? Okay, so I'm going to continue with partner. Actually, I'm going to continue with partner B on the left. So when you're doing expected value and standard deviation, you basically just have to remember the formula. So let me go steal the formula off the math chart. It's over here. All right, so if you scroll over here on the math chart, these are the two formulas you need. So I'm actually going to steal them from here. I'm so clever. Oh, too clever for my own good. This is the formula we're using, okay? That's from your math chart. And here's the formula for the standard deviation. Right over here. Okay, so I'll copy that. Put it over here. So there are your formulas. Basically, you know n is, right? You know n is, let me move this out of the way just a touch. So we state n is 200. P equals 0.06 because this is partner A, right? And we don't need an X on this. That's all you need. All right. Same thing here. N is 200. You don't have to rewrite it. But it's a good idea anytime you're doing one of these problems, identify those values. All right. And then 1 minus P. So you have square root. So you have 3.359, right? Then how do you do so we have the standard deviation, you plug that in, and there you go, okay? I don't have the pretty square root because my square roots have been funny. I guess I could draw it. Maybe I'll fix it for your final draft copy. Then, using the mean, standard deviation, the standard deviation, and a normal approximation, how many goggles should we have if we want to have enough, this should say enough, 75% of the time. Your copy does say enough. All right. So we have this mean. So we have 12 and 3.359. So there's my normal distribution. And then notice I just did the less than. The reason I did the less than is that on a normal distribution, it's continuous. So I can say exactly. Now, in the old days, I actually used to do a 0.5 adjustment. So I would go up to something 0.5, in this case, whatever it is, and go from there. But and the reason we're doing this is if I wanted to know how many goggles do I need to know 75% of the time, here's the reason we're doing it this way. On the TI, second distribution, do we have inverse binom? I'm not sure. Maybe we do. Ooh, there is an inverse binom. That's interesting. So So we're going to play with this. Might as well. It's 200. So this is going to give me an area of 75%. 14. Oh, that's nice. It gave me a nice rounded number. So it gave me 14 is the correct answer, which, oh, wait, actually, that's not enough. That's not enough using a normal approximation. So, ooh, that's going to give me the wrong answer. Oh, well, so we tried it. Okay, so what we're going to do is we're going to do a normal approximation. Okay. And we're going to do, we find we know the area is 75%, and we want 75% of the time to be at this value or lower. Well, the value that comes up is 14.266, but because it's higher than 14, we're going to say we need 15. All right. So don't use the inverse binomial. All right. Sorry. Don't do it. Let me see if it does it here. No, there's no way. It doesn't do anything inverse at all. There is no inverse binomial in Staplet. So, but there is normal. Let's go use normal. So the mean is, in fact, that's how I made my pretty pictures. We want calculate a value corresponding to an area. Left tail, 0.75. And labels on plot, so you have beautiful work. And there you go. That's it. And by the way, let's go play with the numworks. Let's see what happens. So I could, first of all, I could go to, let me scroll over here and put in 0.75. Oh, wrong. Yeah, wrong distribution. Let me go do the other side since I'm on this one. So this one is standard. So there's your mean, 15. Standard deviation is 3.814, using the same ideas. And now let's see what happens here if I do this. Oh, hold on. I want at least, will it take it, 0.75. And it says 17. So it did give me, oh, that's interesting. So it's pretty smart here. So I put in 0.75, right? And it says, well, that's 16 and a half, but this is a binomial distribution. So I can't give you 16 and a half sets of goggles. So I have to round it up to 17. So it actually does give the right answer. Interesting. I'm becoming a bigger and bigger fan of these calculators. They're very cool. Okay. And currently still cheaper than a TI-84. All right. So they're probably cheaper because they have to be, because TI-84 owns the market. Okay. Practically a monopoly. Let's see. Oh, so anyways, and then if I do, let me go back to normal distributions. Oops, I was on distributions. I got to get out of binomial. Let's go to normal. I think it's near it's near the bottom there. So then I just put in my mean and my standard deviation. My mean is 15, my standard deviation. And then I want to go area, it's left already, 0.75. And there you go. Whoop. Oh, 0.65 here, 0.65 for this problem. So there you go. This is for the right side, guys, sorry. And so I'm getting 16.47. That's not enough. And if I go to the other side, the partner B side, let's go ahead and go back and set those values so they're correct. This one has a mean of 12, standard deviation of 3.359, and I want an area of 0.75 this time. And you can see it's giving me the right values. And that's it. Good luck on your quiz. It actually should be much shorter than this review video because I explained both sides. I did Staplet, numworks, and TI. And then we also talked about Bernoulli distributions. Make sure that you understand what those are. All right. Good luck on your quiz.